One of the exciting things about working on materials at the scale of the atom and the electron is that from that viewpoint, from the viewpoint of those electrons and the atoms, many of the challenges in energy technologies are sort of similar. And so let me give you an example. One of the oldest ways of storing energy is to simply pump water up a hill. And so we build these big reservoirs and these pumps, and it's a very reliable and very inefficient storage technology. It takes a lot of land too, but it works. Well, it turns out that storing energy electronically is very similar. All you do is you pump electrons up a hill, and you have to create those hills and pumps and reservoirs, but for electrons instead of for water. And so you do that by designing the material, designing its optical properties, its electronic properties, in just the right way. But pumping an electron up a hill is exactly what you do in a battery. It's exactly what you do in a solar cell. And it's what we do even in these solar fuels that I talked about. It's what you do in many of these technologies. You simply are using energy in one form to make electrons sort of go up a hill. And then either you keep them there, like in a battery, or you run them through a current once they're up the hill. You let them run back down, like in a solar cell. But from that viewpoint of what's happening in this electrons world, many of the properties we care about and the ways in which we design the materials are cross-cutting across many different applications. And so that's why designing materials from that viewpoint is I think, very powerful and has such a broad range of impact. There are a lot of new areas that we're starting to explore where, again, this idea of understanding and designing materials at the atomic scale can have a major impact. So, for example, recently we showed that graphene can be a really outstanding filter for salt water, and again, and this is actually, I think, a gap in the research field right now, because a lot of the work on desalination is at the systems level, not at the molecular scale design. And what we've shown using simulation is that there is an enormous factor of improvement that can be had by designing new membranes at the atomic scale. And so now, actually, based on these results, we're going into the lab and starting to make these filters and test them. So that's a new area, and I think clean water is a really important area that's getting far less attention than it should. And so I see far too few material scientists working in this area, and so I'm very excited to see how we can make an impact in clean water, which is, after all, tightly connected with energy, right? So that's certainly a direction I'm excited about.